Good morning, students. This is Shiv Shankar Tale from Government Engineering College, Bikaner Mechanical Department. In last lecture, we have seen the working of VCR cycle. Okay, now we'll see the modification to standard VCR cycle for a single stage. The modification is required for the better performance of the cycle. Now, the first modification is subcooling. What happen in actual system, the temperature of the heat sink will be several degree lower than the condensing temperature for heat transfer. We know that in condenser the heat is rejected from the condenser to the heat sink. It means there is a temperature difference, but the temperature difference between them, heat sink and the condenser, is several degree. So there is a chances of the subcooling of the liquid of the condenser. Okay, why we require the subcooling? Because for the better performance of the expansion device, we can say that the cooled liquid to be entered into the expansion device. Hence it is possible to cool the refrigerant liquid to a few degree lower than the condensing temperature. You can cool the refrigerant liquid for a few degree, okay, to ensure that the at minimum temperature of the refrigerant liquid enter into the expansion device. Then the exit condition of the condenser will be in the subcooled liquid region. This process is known as the subcooling. The exit condition of the condenser will be in the subcooled liquid region. Now, what is the effect of that subcooling on this performance of the VCR cycle? What is that effect? That we will see with the help of the TS and the PS diagram. If you see this TS diagram and the PS diagram, that is actual standard VCR cycle is 1 2 3 4, that is without subcooling. 1 2 3 4, here I have written, that is cycle 1 2 3 4, that is the actual or the standard VCR cycle or without subcooling. And after subcooling, what happened here? See, the 4 point shifted to the 4 dash and the 1 point is shifted to the 1 dash, means the with subcooling the cycle is 1 dash 2 3 4 dash, that is with subcooling. Now if you see the pH diagram, what happened with the refrigerating effect? Okay, in actual case, that is without subcooling, the refrigerating effect is the difference between enthalpies of endpoints of the evaporator, that is H2 minus H1, or without subcooling you can say that is H2 minus H1 dash. Now see, the enthalpy difference, this H2 minus H1 dash is greater than H2 minus H1, means the refrigerating effect is increasing because of the subcooling. Now what is the effect of subcooling on the compressor work? There is no effect of the compressor work. Means what happen? You know the COP equal to refrigerating effect upon the compressor work. The compressor work is not changing because of the subcooling, only the refrigerating effect is increasing, means the COP of the cycle is increasing. See, means subcooling increases the refrigeration effect without affecting the compressor work. It means that it increases the COP of the cycle. Reduce the vapor fraction at the inlet to the evaporator, leading to reduced pressure drops in the evaporator. Now if you see in actual standard VCR cycle, the point 1 is there at the entry of the evaporator, and with subcooling the entry of the evaporator is at 1 dash, means here the value of X is reduces, means the vapor fraction is reduced at the entry of the evaporator. It means the pressure, the value of X is reduced. If the value of X is reduced, the pressure drops is reduced. Now the subcooling is beneficial for the performance of the VCR cycle. Then why not we use the subcooling for a more means at more temperature. See, Degree of subcooling depends on the extra area. Means for doing the subcooling you have to provide the some extra area for the heat transfer. Now how much amount of COP is increased, and the whatever you are providing the area, whatever the cost required for that area, okay, that will be feasible for the performance of the VCR cycle. Okay, you have to check that. Next point is heat transfer for the temperature of the heat sink. In for the subcooling you have to reduce the temperature at the exit of the condenser up to the temperature of the sink, or you can say that the condenser temperature is always greater than the heat sink temperature. Why? Because there is required the temperature difference. If the temperature of the condenser and the heat sink is same, there is no heat transfer, there is no heat rejection in condenser. Okay, you can do the subcooling up to the greater than the heat sink temperature. Okay, that is the two main points are there, that the subcooling you have to matlab you have to up you have to do the subcooling up to the only the heat sink temperature. Now next modification is superheating. The temperature of heat source will be a few degree higher than the evaporator temperature, hence the vapor at the exit of the evaporator can be superheated. You know that in evaporator the heat is extracted from the heat source. Okay, you have to superheat the vapor in the evaporator. Now what happen, or what is the effect of superheating on the performance of the VCR cycle, that will see. This is the TS and the PS diagram. See, similarly that is the cycle 1 2 3 4 without superheating, and 1 2 dash 3 dash 4 with superheating. Okay, if you see the PS diagram, increasing in the refrigeration effect means in actual refrigeration effect, that is H2 minus H1, and for after the superheating the refrigerative effect is H2 dash minus H1, that is H2 dash minus H1 is greater than H2 minus H1. Also what is the here, the compressor work will change. Okay, also increase the compressor work because the H3 dash minus H2 dash is greater than the H3 minus H2. Here the refrigerating effect is also increases and the compressor work is also increases. Now what happen with the COP? It depends upon the which factor is increasing more. It depending upon the operating conditions and the which refrigerant or the nature of the refrigerant decides. Okay, you cannot say the COP is increased with the help of the superheating. It depends upon the operating conditions. Now some amount of superheat is always used to prevent the entry of liquid into the compressor. Okay, some amount of superheat you have to given for the proper functioning of the compressor, because if you see the actual or the standard VCR cycle, the entry of the compressor is the saturated vapor. If there is the performance of the evaporator not do at a satisfactory level, it means that the entry of the compressor, it may be chances in the wet condition. It means it goes the mixture of vapor and the liquid into the compressor. I have told already in the last lecture, that is the entry of the liquid in compressor is, it will cause the damage to the compressor. Okay, that's why you have to avoid the entry of liquid into the compressor. So that's why you have to provide the some amount of superheat to the evaporator. Okay, to avoid that problem. Next, now the use of next modification is the use of liquid suction heat exchanger. We know that the subcooling and superheating Okay, it is not possible as per our required temperature. So because subcooling and the superheating is depends upon the heat sink temperature or the heat source temperature. See, this line is required degree of subcooling and superheating may not be possible if one were to rely only on heat exchanger between the refrigerant and the external source and sink. A liquid suction heat exchanger ensure required amount of subcooling and the superheating. Okay, with the help of liquid suction heat exchanger, there is a no limit of temperature for the subcooling and the superheating. A liquid suction heat exchanger is a counterflow heat exchanger in which the warm refrigerant liquid from the condenser exchange the heat with the cool refrigerant vapor from the evaporator. Here you have to add one heat exchanger, and that in that heat exchanger, okay, the heat is extracted from the hot liquid of the condenser to the cold vapor in the evaporator. That we'll see with the help of diagram. See, if you see this diagram here, the evaporator, the process 1 to 2 is evaporator, and this cold vapor from the evaporator goes into the this liquid suction heat exchanger, that is process 2 to 3, then 3 to 4 compressor, then from condenser, then hot liquid of condenser comes into the liquid suction heat exchanger. Means here in this heat exchanger, the hot liquid of the condenser exchanges heat with the cold vapor from the evaporator. Okay, means here both the functions are here. The subcooling is also done, and the subcooling of this liquid of the condenser is done, and the superheating of the vapor is also done. The process 2 to 3 is the superheating of vapor, and the process 5 to 6 is the subcooling of the liquid. If you see the TS diagram and the PS diagram, that is 1 2 3 4 3 4 5 6. 1 to 2 is the evaporating process, 2 to 3 is the superheating, 3 to 4 is compressor, 4 to 5 is condensing, 5 to 6 is the subcooling of the liquid. Okay, here you see the temperature difference. Here the temperature, that point from 0.5 to 6, the delta T, that means here the subcooling of the liquid of the condenser takes place. Here the temperature difference is 2 in between the 0.2 and 3. Similarly, same cycle is represented on the pH charts. Now here what will happen with the COP, that we'll see, or what is the effect of this adding extra equipment, that is heat exchanger, what will affect on the performance of the VCR cycle, that we'll see. Okay, heat transfer in the liquid suction heat exchanger. Now how you calculate the heat transfer? Heat transfer is calculated by the mass flow rate into change in enthalpies, that is Q equal to mR into H5 minus H6. Here the whatever the amount of heat released from the hot liquid from the condenser, same amount of heat is goes to the cold vapor of the evaporator. Means mR H5 minus H6 equal to the mR H3 minus H2. mR get cancelled. You can H5 minus H6 equal to H3 minus H2. If you take the average CP values, H5 minus H6, you have to write here in terms of temperature. That means here the exit condition of the condenser, means at the exit condition of condenser liquid is there, means Cp of liquid into T5 minus T6 equal to Cp of vapor, which is the exit condition of the evaporator, T3 minus T2. Okay, we know that the Cp of liquid is greater than the Cp of vapor. If there is a Cp of liquid is greater than the Cp of vapor, it means that the T3 minus T2 is greater than the T5 minus T6. Because of these two equations, T3 minus T2 is greater than T5 minus T6. If there is a T3 minus T2 is greater than the T5 minus T6, we can say that on this basis the degree of superheating is greater than the degree of the subcooling. Means with the help of or with the using liquid suction heat exchanger, the amount of superheating is uh, done by that heat exchanger is greater than the amount of subcooling. Okay, or what is the effect of CUP of that adding the this heat exchanger? Okay, that also depends upon the nature of the fluid or the operating condition, because the degree of superheating is greater. Okay, it may change from the practical application to application. Okay, thank you.